in general are helping companies find and attract best talent for their HR needs, mostly dealing with experts in the IT field and, of course, exciting companies on the other side, connecting candidates and experts with new opportunities. So let me take advantage and invite everyone, if anyone here is open to explore new opportunities, feel free to get in touch with us directly, and we will see what we have to offer at the moment, as we are working with top companies from the industry. Also, in addition to that, we are here, our aim here is to build a community of great talent, experts in the IT field who are eager to share knowledge and also learn new things. One of the key pillars in helping us build this community are also events where we can gather our friends and experts from the industry to then share knowledge and have exciting discussions, such as will hopefully be this one today. With that in mind, we are also moderating a Facebook group called Adriatic Developers. So please feel free to also join us there. This event is also streamed live on this Facebook group. I think that this was enough about us. Now let's focus on you, starting this event with Matteo Collina, who is principal architect at NearForm, and will discuss the topic of GraphQL. After Matteo's talk, Miha Medven Simon Belak and Peter Keše will join and discuss the future of JS with all of you guys. So enough said, let's start. Matteo, you can take over.
Hi, everybody.
Hello.
Hello. I am Matteo Collina. A lot of people being streamed here. Very happy. So bear in mind, this talk is first time that I deliver it. So let's see, that is the first big show for today. So it seems that the OS disabled screen sharing. So I need somebody to enable screen sharing for me, folks. Or make me co-host or something. Anyway, you can open Twitter in the meanwhile and follow me at Matteo Collina. So you know, just to be
co-host now. So I think...
okay. So now I am co-host.
Mm-hmm.
Okay, here we go. Now you can see my screen, right? Can you confirm you can see my screen? Amazing, folks. Okay, so. I'm going to talk about GraphQL and GraphQL caching precisely. Okay, so it seems hot topics these days. Little bit about me, who I am. I'm Matteo. I'm Chief Software Architect at NearForm. I'm also a member of the Node.js Technical Steering Committee. So means I'm part of the people that maintains Node, essentially. So if I put a bug in, you probably start screaming very badly at me. Point. I've co-created the Fastify and Pino framework, and I have a newsletter. So nodeland.dev you can take and open up on your Twitter or browser or whatever, and you can just follow me. Sorry, subscribe to that newsletter. So if you care about these topics, you probably want. So okay, let's get started. So let's say that I am when I was a kid. I don't know if you. I was dreaming of seeing a David Copperfield show. I don't know if you have been, I don't know, this tells a lot about how old I am and what generation I was, okay? But when I was assembling this talk, I wanted to explain magic, okay? And make sure that, you know, there's no magic and I'm explaining the tricks, okay? So, yeah, it's something. So today we're going to have something disappear, and then I will explain the trick. So let's see how well can we do it. So what I'm going to show you today is how we can improve the performance of your GraphQL gateway by 4 times. That's it. Okay, so we can improve the performance. So tool of the trade. What are we going to use today? First thing, we're going to use Fastify. Fastify is a really fast web framework for Node.js. If you're not using Fastify, you probably should. So I created it. So trust me, but no, don't trust me. Try it out and use it. Okay, it's good. Also, I'm going to use Mercurius. Mercurius is an implementation of GraphQL that I wrote on top of Fastify. So those are the two main things that I'm going to use. Well, not true. I'm going to also use a library called Autocannon. Autocannon is a load testing tool for Node.js. Again, it's all part of things that I built. So at this point, let's call it the Matteo stack. So let me show you how is the system that we are going to test. So first of all, we have two services, and one for users and one for posts. And we are assembling them using a gateway, okay? We also have just-in-time compilation enabled. This is one of the phenomenal features of Mercurius that enables a greater level of speed. So all of this, anyway, it's enabled all the time, right? So also the target services do nothing, so they just serve data from memory. So what changes is that we can enable and disable caching just by changing the arguments of our process. So that's what we do. Okay. So this is an example service. So it is the user service, but the post service is very similar. So what it does, it's essentially allow you to fetch and resolve a user, right? From memory even. So it's not, there's not much here to talk about. Okay, it's time for some magic, right? Are you ready? Hopefully so. So this is our baseline. Oh, well, let me show you the magic actually. So, oh no, I want this one. Where is it? Okay, so clear. So this is the magic. I hope you can all read my terminal. If you can't read my terminal, well, I'm sorry. So let's hope you can read it. Otherwise, I can really show you the magic. So let's open up our benchmark script. So our benchmark script, what it does, it starts up the two services, and then it spins up the gateway, and then spins up starts the bench. Okay, the code is what I showed. Well, we can even check that the code is what I showed you. So it's the gateway, well, with a minus difference because it's the new import syntax is better in the slides, but that does not change it. So this is the same. This is the other service. Okay, so again, same stuff. And this is the other service of the post. Exactly like very, very similar content. Just serve things from memory. Okay. So what does our bench look like? Our bench look like this. So basically it goes and it executes this query, which is a valid query for this diagram, okay, for this. And it's just a lot of times, okay? So it uses 100 concurrent connection to create a lot of load in our gateway. Okay, so let's run this, okay? So if let's say that I'm running this, so this is the known cached stuff, and you can see that we are running it. Note that I'm not running this code on my machine; it's running on a server, so you're not going to see anything here. So on this first one, what you are seeing is our baseline. So in our baseline, you can see that we have a latency of 80 milliseconds and 3,000 requests per second for this gateway, which seems pretty good, right? You know, I'm not benchmarking Apollo, so I'm benchmarking my own code. Okay, but try doing the same with Apollo if you want, or other implementations anyway. So what would it look like if I unblock this? Okay, so let's see what happens with 0 second time to live. So it's a cache that's been kept alive for 0 seconds. It's not caching anything. It's basically just existing. It literally boosts our number of requests per second, the median, at 4x. So from 3,000 bumps to 13,000. What? How can this be possible? Just change a few lines, okay? That's the wow effect, okay? So let's go to the slides and see where are my slides, okay? My slides, okay. Let's talk a little bit about it. So this is our baseline, okay? The baseline is latency P99. That's the number that you want to measure. Is the 99th percentile. It's 80 milliseconds. Then the median number of requests per second, it's 3,000 or some more or less. And then we have the throughput. So I'm also an engineer. So I'm an engineer. So I tend to get deep into things. Okay. And if I do a flame graph of our base code, that's what it will look like. Okay, of the baseline, that's what it will look like. So what is a flame graph? A flame graph is a way to represent graphically what our application is doing in that amount of time where we are benchmarking. That's a benchmark. It's a tool called Clinic Flame. You can check it out. It's all available online. So it's a very important part of the work that is being done. Okay, so this is the ongoing HTTP request, this outgoing HTTP request. So it's spending a lot of time in doing the outgoing HTTP request. It's a lot of work, okay? It's sending a lot of data throughout to all the other services. So what I started asking me is, how much can I improve this, okay? And the answer is quite a lot, 4 times. So, and these are with empty servers. Now, the difference can be way bigger for actually real life database services. So what happens is that even with no 0-second TTL caching, as I call it, it's 4 times. But for 1 second, it's still 4 times. Okay, it's not changing much. Okay, it's not changing. Why it is not changing? Huh. We'll explain that. So this is the new flame graph. Did you notice what it's missing? It's not actually doing any outgoing HTTP code. In fact, there is a significant big block of code now that is being spent dealing with the cache. So what we're doing before, we were doing a lot of HTTP calls and so on and so forth. Now we're spending a lot of time in the cache. And if by looking at it, there is some recurring pattern by looking at this diagram. We see get key, stringify. What are these bits? Okay, why is this a problem? Now let's explain the magic. Okay, where did all the HTTP code go? Well, the magical thing is about deduplication. And if I'm talking about cloning stuff, I needed to put a reference from Star Wars. So anyway, let's talk about the Node.js event loop. This talk is going to get very deep, very quick. Okay, so be careful and follow me. So you have the Node.js event loop that it's circling. Okay, it's processing the things. Well, you probably have seen this diagram before, or something very close to this diagram. You probably have not seen this diagram. So what happens when we get an event loop, when the event loop process? So essentially, normally the event loop is waiting. So there's nothing being executed. It's waiting for an event. When that event happens, the event loop calls a C function, which in turn executes your JavaScript code. In that JavaScript code, then you schedule typically a lot of promises, okay, and next tick. After that's done, it goes back to C++, go back to processing all the queue, and after all of that is done, it goes back into the event loop to wait for more events. So the end result is we want this flow to be fast, right? Now, it is the trick, and it is the magic, okay? I'm explaining the magic here. So what we implement is a dedupe cache. What is a dedupe cache? So when you execute a JavaScript function, you can, it's basically a memoization technique, if you want to call it with another term. So when you call an async function that will return a promise, first of all, I create a cache key. And with that cache key, I put the promise that will resolve from that cache, from that thing, into my dedupe cache. Now, be careful, because this is very tricky to get right. Otherwise, you'll get a memory leak. So, don't do this at home. Kids, be careful, okay? But it's totally safe here. So what we'll do is, at the first execution, we put something in the cache, which is one is a key, and the other one, it's a promise. Now, when a second query comes in and wants to have the same data, we can get the cache key, and with the cache key, we can get the promise, the pending promise. So we can avoid invoking the real function more than once at any given time slot. It's a pretty powerful technique. So if we have 100 concurrent connection or 1,000 that wants to do the exact same computation, we can only do the same computation once. Okay, now we understand your trick, right? You implemented this. Yes, that's how it works. There is this little module called async cache dedupe that I wrote over the summer. It's pretty fast, and check it out. Okay, this implements this pattern, exactly this pattern. Okay, it's a little bit tricky, and it does not have memory leaks, but it's tricky. So you prefer to use these modules than roll your own. Okay, or if you roll your own, be very careful. There is a lot of edge cases that are a little bit nasty to fix. So, well, we still have a problem, right? How can we compute a good caching key? So we need to get that cache key to, how can we roll that cache key, right? If you want to do this magical thing. So let's look at the resolver. So our GraphQL, how do we implement a GraphQL resolver? So in GraphQL, you get 4 parameters. In JavaScript, you get 4 parameters when you implement a resolver. So you get you get the root object, you get the arguments for that function, for that thing, you get the context, which is typically the HTTP request, response, and so on and so forth, and an info object. The info object contains the information about the actual query being computed. So we could actually use some of this information to compute a cache key. Well, what can we use? So there is this technique called stable JSON stringification. So a stable JSON, it's a JSON that independently of the type of object that I'm putting through, I'm getting the same JSON out. Now, look at this example. So we have that if we invert the order of 2 keys in a JSON file, we will get 2 different string representation. Sorry, on a JavaScript object, we will get 2 different string representation when we pass it to JSON stringify. But if we use the safe stable stringify, we won't. We will always get the same. So we can use the JSON representation as a cache key. That's unique. Okay. So as we see, though, this is probably the main bottleneck of our application of this system. So maybe if you know about the algorithm, let me know. I would be very happy to follow. So we still need to compute the object that we use for the cache key. It's pretty simple, but we're going to use the argument, the object in which we are calling the node. We are going to use the argument for those things. We are going to use the fields that are being selected. This is very important, okay? And we will have this extend key, but don't worry about it. So, what does a 0-second time to live mean? Well, it means that we are only going to dedupe. So we are not having any caching involved. And it's fast. Note that there's not very much difference in this system by using by adding time to the cache itself. Okay, so it's not growing much. Okay, is not improving much more, mainly because the hardest thing we need to compute is the key. Okay, so that's where things start getting. So, well, we haven't finished yet, right? So in-process caching, caches are problematic. Typically means the data gets out of sync between multiple processes. You probably have been familiar with this somehow. You also get the risk of memory leaks, and then there is still some load going through, going upstream, as multiple processes must have a low TTL, so we can't cache for long. So the solution is to store data in Redis. So after we implemented all of these and we were doing load testing to put it in production, we put it in Redis, and it did not work at all. We were super depressed. So, and if it was a real magician with a chainsaw, I would have cut the assistant in half at this point. So, or maybe not. Wait a second. So let's do a little bit of math, okay? So let's say that we have 100 concurrent queries, GraphQL concurrent queries per second. Each one of them invokes 20 resolvers. This means that we have 20 resolvers times 100, which means 2,000 Redis get per second on my cache system. So, well, the time it takes to go back and forth on Redis in the worst case is 15 milliseconds for each one of the requests. So it does not work, right? I can't fit those many requests per second on Redis. Are you sure? Like, is there a solution? Well, yes, there is a problem. This is called head of line blocking. So if you tend to do all the Redis query one by one, you have end up to have the problem of head of line blocking. Now, luckily for me, I already fixed that problem. We already fixed that problem. Okay, so I already had the solution available. I'm literally pulling another rabbit out of my hat. Okay, and if I do this talk again, I will have a rabbit out of it to bring up. But this is a miss. I can go and fetch out one of my daughter's toy. That will be pretty nice. So anyway, this is a problem that we have already fixed. So go and watch this talk. But let me summarize it for you. What we have implemented is a technique called auto pipelining. Redis auto pipelining enables you to definitely boost your interaction within Redis. So it's very similar to what we talked about before. So you have Node.js event loop, and you have a bunch of commands, and all of the commands in the first iteration are getting queued up in a Redis pipeline. So Redis pipeline is essentially allows you to send multiple commands at the same time in one batch. So Redis can then send all of those things back to you in one response. So in this way, you remove all the network round trip time to talk to the Redis server. Wow. So, and all the other things get put into pipeline 2, and all of that gets back, and so on and so forth. So these enables, in our test, enable to squeeze down the time needed for talking to Redis to nothing, almost. Okay, so we could take all those Redis HTTP requests or those Redis GET requests and basically squeeze in a very, very tiny round trip time. So does this sound familiar? Haven't we just used that stuff? Well, literally, this is just turtles all the way down. Okay, and if you're not familiar with Discord, please go and read one of the books of Terry Pratchett. Anyway, let's go and talk a little bit about real-life statistics. So in real life, we have deployed this on one of our clients, and we got an improvement of 100 times using the same servers. And well, the part of the problem also was a 15 times expansion factor in Redis. So for each of those HTTP requests coming in, we were doing more or less 15 commands on Redis, which sounds quite a lot. So it was quite a fun. Creates a little bit of load on Redis, but you know what? Redis is fantastic. So you can throw as much load as you want to Redis, and everybody's happy. So I very much, I've only seen it fail once, and only because it ran out of memory. We were caching a little bit too much at that time. So, well, I haven't finished. Okay, I don't know. I still have probably a little bit more time of time in this talk. Turns out that there are two other things in computer science. I hope you know where I'm going. Okay, one is cache invalidations, and the other one is naming things. So now we are going to talk about cache invalidation. How do we invalidate the cache? And we are working on it. Okay. So it's we are working on it. We have a draft PR and work being currently developed to do it. It works. All the proof of concept works. It's just not on a shape to be able to share it with you and to share numbers with you. But it works. The reason why it works is because Redis is a fantastic system, and you can implement very complex data structures on top of Redis. So that makes it possible. Anyhow, thank you very much for your time. Let me talk a little bit about NearForm. So NearForm is a professional services company. We are based in well, the company is an Irish company at this point, but we have people in 28, I think, different countries, and we are adding all across the EU, especially in Europe, especially in Eastern Europe. So if there are a lot of roles, so check us out. We are hiring, and we'll keep hiring for the next for the whole of next year, considering our growth path. So if you want, that's the kind of problems that we face and so on. So thank you, folks, and that's all.
Cool, Matteo. Thank you very much.
Thank you.
Yeah, thank you. Okay, let's go to the next part of this event. My colleague and our associate colleague from the company, Sara Gaspar, will help me, introduce also the next stage of this event, and also introduce our next panelists. Sara, please take over.
Yeah, thank you so much. First, thank you, Matteo, for taking your time. But before we move on, I would just like to ask everyone, if anyone has any questions, now is the time. Ask them, or it's going to be forever unanswered.
Do it.
Okay, so should I read it out? Matteo, do you see, or should I read it out?
Yeah, I can see it, but if you read them, it will probably feel nicer.
So Matteo is asking, Matteo, based on what mechanism you batch delimit the comments to the Redis pipeline?
Okay, that is actually a nice question. So the mechanism so there are two mechanisms. The first one is up until the previous pipeline completes. So it sends one pipeline with all the comments, and it keeps batching all the other comments up until the previous one completes. Okay. Now this is the first mechanism. However, there can be too many comments inside a pipeline. So at some point, this technique gives you diminishing returns. So you don't want your pipeline to get too big. So there is always also a fail-safe to I think limit it at 1,000 or something like that comments, which is more than enough.
Okay. Yeah, thank you. Anyone else? Enrico, are you planning to have a version of Mercurius running on workers, something like Cloudflare Apollo server?
This is another very nice question. the answer is no. The main reason it's workers do not support Node. Okay, it will be very complex to support Node in there, and even if we wanted that, there is a substantial amount of code that will need to be uploaded and run. At this point in time, it would be very complex to make that work. And unless somebody has a very, very good use case for it, and especially that is willing to invest some money to fund some of that development, that's not going to happen. The main hard part is actually getting Fastify to run in workers, not really Mercurius related. Once Fastify runs in worker, it will run in, it could run this as well. And by the way, Cloudflare might do that in the future, right? Rita, if you're watching, hi Rita, hi James, if you're watching, you know. If people watch the tweet to Cloudflare so that they will get Node running on workers and that they listen.
Okay, thank you so much. I think we will just we will go now solely on the second part to just enter a little bit more in the debate and include also other panelists. But just before we do that, I just want to make a short introduction. So first, joining Matteo for the second part in the panel about the future of JavaScript ecosystem is going to be Simon Belak as the moderator. He's known to all Slovenian developers as a growth hacker, as a philosopher, a public speaker, a data advocate, theater director, and also a tech talent enabler, helping companies to fix broken hiring processes and also empower developers to go after positions they want. And he is also a self-described JavaScript hater, so this should be very, very interesting. Then participating in the panel is going to be Peter Keše, a senior developer that has started programming before internet was a thing. And he was hacking supercomputers in Australia in the 90s, has given a lot to the open source community as a former Linux kernel networking stack developer, and helped advance computer science and even medicine with his contributions through research and development. He led the Slovenian national team on World Olympiads in informatics for 5 years, and is currently working as a head of data science at HTT Pool. In terms of stack, Peter has used everything there is to use. And then joining them is going to be Miha Medven, moderator of the biggest Slovenian community of developers on Facebook, and he's also our salary fairy, since he is the one behind the yearly wage survey that is a Bible for Slovenian developers and employers alike. He has been working in different lead and CTO roles, mostly in startups. He's a developer and a user experience researcher, and he is a TypeScript Angular developer, lately also discovering the magical world of React, finally. And before we jump in the debate, I would just kind of like to give you a very short insight into the JavaScript job market at the moment. And then Miha will hopefully just tell us a couple of sentences for the Slovenian market in particular. And then I will give the floor to Simon. So just very briefly, as Sarah told you at the beginning, we are recruiters, so that's why we kind of wanted to give you some value added also from this perspective. There is around 27 million developers on the planet, and in the global survey from Statista made this year, that pooled more than 80,000 respondents, almost 65% of all developers use JavaScript, making it the most used technology. It's followed by HTML, CSS, Python, SQL, and Java, but on the 6th and on the 7th place, we find TypeScript and Node. Obviously, multiple answers were possible, so that's why the percentage is so high. But then also, according to Stack Overflow, JavaScript is the most commonly used programming language on the planet for the 9th year in a row, and even backend developers now are more likely to use it than any other language. On top of it, this year's Stack Overflow developer survey shows that not only most people work in JavaScript, but these are also the most wanted technologies, with 3 out of top 10 wanted technologies being from the JavaScript ecosystem, totaling more than 40% of all responders. And here only one response was possible. And then in terms of salaries, I just kind of wanted to give you the Stack Overflow global data, since we are from different countries and I didn't want to go country by country. But definitely JS right now is not really going to bring you the most monies in terms of programming languages. But just to give you a clue, TypeScript has a median of around 60K yearly, while Node.js devs earn around 55K yearly. On the other side, when it comes to web frameworks, 2 out of 5 most paid web frameworks are Svelte and React, with Svelte devs earning around 62K and React devs earning around 58K. And the most paid web framework right now is Ruby on Rails, just putting it out there. So what comes next? Well, DevSkiller unveiled some interesting insights into current developer hiring trends. Based on their analysis, they found that 72% of companies are looking to hire JavaScript developers. And meanwhile, a report by HackerRank found that the global demand for JavaScript outweighs the expertise available on the market. So they kind of pulled and said, okay, more than 53% of employers worldwide say they do need JavaScript skills, developers with JavaScript skills, but only 42% of student developers say that they are proficient in the language. So to conclude, when we check the global remote market, obviously, we are a lot of times, of course, talking about startups and younger companies, and in particular, and they do mostly use JavaScript-based stacks. So most of new greenfield projects are coded in JavaScript. There is also most remote positions in JavaScript. If this is good or bad, the guys will discuss later, but we can definitely conclude that in terms of jobs, JavaScript developers have and will have the biggest choice and a lot of options to work on new projects in flexible environments. And with this, super quickly, I will give the floor to Simon and ask him to start the discussion.
Thanks, Sarah. Like I've already been introduced, I am, to put it mildly, somewhat hesitant about JavaScript as such, but I also do recognize it as being by now one of the cornerstones of a modern ecosystem. So in a lot of ways, this roundtable is going to be an attempt to wrap my head around where the future is and what kind of opportunities lie in this, even beyond just the JavaScript as a language. So kind of, this is going to be pretty free form. So like I'll ask you both to just kind of, all three of you to just jump in with the answers. Like I'm not going to direct questions at one specific person because I think that's kind of a lot of stuff gets lost, but I'll maybe steer some questions to one of you, but otherwise just kind of jump in if you think you can say something interesting, which I'm sure you massively can. So kind of as a warm up, can each of you tell me about some of the projects or trends you see in terms of either the development of the language as such or the tools and tooling around it that you find particularly exciting?
I'll start. I think the biggest problem and the biggest unique selling point of JavaScript is that 60 or 70% of all development is web development. And until a few years ago, the only programming language that you could use was JavaScript. So everybody used JavaScript because if you wanted to do front-end development, that was the programming language to use. And that was its main selling point. And that's why it's so common, because there's no other options. Well, there is now, but a lot of years ago, it wasn't. So what I find personally very welcoming is all of the things that are coming with TypeScript or came with TypeScript and Kotlin and superset languages, where they take a programming language and improve upon it. So you're actually using a useful language, quote unquote, and still able to run on the platform that you want it to run, because TypeScript compiles or transpiles into JavaScript, runs in your browser, and with faster CPUs and faster mobile devices, more and more load is getting shifted from the backend to the front end, because, I mean, it's free resources. And hopefully the advancement with Rust and WebAssembly will take the shift or the like priority of doing JavaScript into other languages that are probably more suited to a better development experience than purely JavaScript. So TypeScript, WebAssembly, Rust, and all of the tooling that surrounds the whole transpiler, compiler ecosystem that's being improved upon.
I disagree on the comment of JavaScript being not great. Okay, I love JavaScript. However, there are very good trends there. Okay, so there is a trend on WebAssembly going on, and being able to use different languages, different libraries on the web. It's great. We should be doing more, and it will happen that we're going to do more. JavaScript is a nice language. It's not, there are certain things that it's very good at, and there are certain things that it's not very good at. And using other languages for things where JavaScript is less good at, it's great, and definitely it's going to happen more. However, I don't think those will wreck JavaScript, or they will supplant JavaScript in any form. The main reason it's JavaScript as it's a really quick learning curve. Every other language that you compile to WebAssembly and you run from there have a much steeper learning curve. It takes way more time to master Rust, C, even AssemblyScript. It takes more time, okay? It's for more advanced developers. And given the amount of people that are joining the industry these days, I don't expect these to JavaScript as a language or as a platform to disappear. What will happen is we'll probably see more TypeScript, and that I totally agree. So the other trend which it's happening these days, it's we have been for a decade on the tooling train. So the web development pipeline got super complex, and we got building tool chains that took 20 minutes, half an hour to build a single website. I don't know if you've seen those, but I've seen those. They are incredible. Okay, the complexity, it's incredible. To clarify, in some cases it took less time to build Node.js, including V8, OpenSSL, and so on, than to build a Gatsby website. I don't know. It was too complex. Okay, it has become too complex too soon. Okay, and given with all this complexity in the ecosystem, we have seen that the tool chain, it's a lot of developers, especially newbies and companies alike, they're just like, well, all of this is too complex. Okay, it's too hard to maintain. There's a lot of bugs. Requires experts, because in order, when you have complexity, you need experts to master that complexity. What we are seeing is a reverse in that trend, so that we have seen simplified tool chains, reduced tool chains. So there is and more pieces of that tool chain are getting collapsed into one tool that does multiple things, keeping things simpler and faster. So tools like, I'm a huge fan, for example, of Vite and ESBuild and SWC. Those are all great examples that moved into this direction to actually simplifies a lot of that development tool chain that has become extremely complicated. Like maintaining the Webpack config has become a form of art at this point, at least in certain projects. Yeah.
So am I around? Okay. I'd actually, I'd like to give like a 10,000 meter approach, and then at the end, just like to wrap up, also give a an idea where I think that JavaScript is going to go in the future. But the 10,000 meter approach, I think, is like, I've been programming for almost 40 years now. And I think that the software industry and the languages and everything, I'd agree with Simon, is pretty much broken. So JavaScript is just another broken language that millions of people tend to use. But then at the same time, I think that JavaScript is really in a really special position, because it's flexible and modable and composable enough that you can use it in all these different situations where, for example, you could use other languages, like either, if you want to add something to Python, you technically mostly write wrappers for C libraries and so on, whereas in JavaScript, the actual development and innovation is happening in JavaScript itself. And quite often I've been impressed at how efficiently and with how little code you can express yourself in JavaScript. In the past, I've been using this Feather.js on the server side, and it was just miraculous comparing to Python backend stuff. So what I think is that JavaScript has brought us all of these interesting technologies, like just-in-time compilers. The current version of just-in-time compiler in JavaScript is pretty much more evolved, I'd say, than what Java or .NET or the others have. We've got all this live reload technology. We've got React, which, okay, truly it was invented in other languages and then ported to JavaScript, but at the same time we got this thing that we learned how to split the store from the rendering process, which is now also again being adopted back in Java and .NET and in other worlds, and I think this flexibility is just going to stay around, and we're in for lots of more innovation around this JavaScript world. Then for the other thing where I'm looking forward for the future is all this web GPU stuff, which is going to bring all this sort of data science thinking and so on, and make it accessible and available to all developers. Like nowadays, every laptop, almost every computer now has some sort of a GPU, even if it's built in. So JavaScript is going to and the browser technology is going to make this accessible, not just through CUDA and not just through people who have like NVIDIA cards, and they'll be able to learn all this new stuff that we haven't up until now. So yeah, so that's my wish for the future.
A couple of things that came up. The first one was, Matteo, you mentioned target, but on the other hand, like a lot of the languages that transpile to JavaScript, let's say ClojureScript, my favorite, target JavaScript as such rather than going for WebAssembly. Do you think going forward more languages are going to switch to going to actual WebAssembly, or are we always going to also have JavaScript as a major compilation target?
I would, it depends. So it's JavaScript happens to be a good target for scripting languages, specifically because you don't have to deal with memory. With WebAssembly, you get essentially a program gets a chunk of memory in which it can run, and it does not have a garbage collector. So which is your best friend and your worst enemy, right? So you could be much more efficient inside WebAssembly because you don't have a garbage collector, but that comes with responsibility. So it's harder.
Okay. But if JavaScript as a compilation target is there to stay, and now this is again like a question to all three of you, how important do you see this aspect of translation to JavaScript? Is it so important that, for instance, JavaScript should remain a stable compilation target like you have in C or C++, where it's kind of basically everyone knows what's targeting? Or is it fine if it's still developing as a language as such, and you have this kind of a constantly moving target of what then your kind of target is, what capabilities it has and how it does things?
My take is that we want, like, I come from a generation that was building websites on GeoCities, and part of how I learned was by right-clicking on a website and doing view source. So I've learned reading other people's code and copying it ruthlessly. And so if I would like to have a world with less tooling and a more transparent web versus more tooled, and where JavaScript is just a compilation target. I don't know if that answers your question, but hopefully so. I don't think JavaScript is going away. People will still need to write custom JavaScript. The thesis 39 will keep pushing and adding new features. Keep in mind that a lot of the features that it has been adding are things that are missing in the runtime at this point. So they're not really, like, there has been some sugary things in there, but a good chunk of the latest things that have been added are not, like, are fundamental primitives of the language. For example, like consider promises or async await or generators. Like those things, if you took the output of what Babel will generate for the async generators in your code, it was like, oh no, you want really this to be implemented you don't want to build it on top.
Okay, great, thanks. Miha, Peter, any one of you want to add something?
I think. Sorry. Go on ahead, Peter.
Sorry. Okay. Yeah, so I actually think that the interesting thing with JavaScript is this Babel transpiler, which really allows for the community to try new approaches and new things, and before they're actually being added to language, which we've just heard of a few examples like async await and generators and so on. But in general, I'm perfectly fine with both Java evolving and JavaScript evolving and also becoming as a better, or just using it as a transpiler target from other languages. So I'm actually nowadays mostly doing most of my data science visualizations and so on in F# by transpiling also to JavaScript and making visualizations in browser. And I'm totally open with that. I love JavaScript. I love F#. I think we're all just winning in any way by JavaScript getting more attention and development efforts.
Yeah. My point is exactly. I think it's all about pressure. If other programming languages, even JavaScript, if it's evolving, it puts pressure to evolve other programming languages, to evolve other frameworks, to evolve communities. Because a lot of things that JavaScript brought to the table, other programming languages adopted, and it was for a betterment of all programming languages and a new way of doing things. And it works in reverse as well. There are pressures doing things to JavaScript that it has to evolve to either fix the things it has to fix and to adapt to things that the community or the trends are going forward. So I think that what we have to do as developers is just put pressure on each other, because that's the way how we evolve. When Ruby on Rails came on the scene, frameworks changed because it brought a new way of doing things, and JavaScript is also in that range. So I think I agree with Peter. It has to evolve, even if you're not using it, or even if you're like a hater. A good JavaScript means better things for your programming language or your framing as well, because we like steal good ideas and try to adopt them to various other like programming languages and frameworks. So I think the evolution and the development of a programming language must never stop, because it helps everybody, the user and the non-user.
Okay, now with like from both directions, both with languages compiling to JavaScript and also JavaScript via something like Node.js encroaching on the server side, we now do have this promise of sharing the same language between the front end and the back end. And the benefits are pretty clear, at least like the sales pitch is pretty clear, kind of recode, reuse, less technology spread and so forth. But what are, in your experience or in your mind, the downsides or pitfalls of adopting this kind of one language across the entire stack approach?
So there is one main downside, okay? And it's typically not on the developer, okay? Typically a company, when you need to staff a project, they staff it using, if it's a complex project, they will require a few people. So they will add, I don't know, 3, 4, 5, 6, 7, 8 at top. If you work for a company where people are more than 8, run in the same team, run. Okay, it's not a good. They don't understand anything about engineering management. So, and if you're a manager that's managing such a big team, split it in two. Okay, you're spending too much time in communication overhead than it's worth. So split it in two. Anyway, apart from that, digression. So you have this team. Now, the fallacy of that approach is to consider all the developers equivalent. Okay, you can have the same language on the front end and the back end, and this means that the impedance barrier between one helping out the two developers working on both sides is smaller, but it still is. Okay, it's very hard to assume that a front-end developer that can optimize the rendering time of CSS can also work in optimize a SQL query. Like, it's two separate skill set. Okay, there can be somebody that can work very well on the front end, that can create a very, very polished design, and this person can also implement a feature on the back end if it's needed. And there can be a backend engineer that is really good at modeling data on databases and so on and so forth, and creating REST endpoints or GraphQL endpoints. Then can also help on the front end by writing a few React components. And in the context of an agile team, this flexibility, it's great. However, the fallacy of the approach is, do not assume that, oh, I can just hire a bunch of front-end developers that are really good with CSS and just give them to design a database. It does not work that way. I've seen the result. Don't do it.
Yeah, I think JavaScript on the front end and JavaScript on the back end is more of a hiring or a HR recruiting clickbait, where you only have to hire one type of person on paper, but in practice, it's the thing that Matteo just said. It's totally true. At the end, knowing in a language is just part of the equation, and the skill sets are very much more important than using the same programming language everywhere. So
it helps. I think it helps.
Yeah, it does lower the amount of onboarding needed, because you don't have to learn a new programming language, which might be a strength or it might be a drawback. It helps, but I mean, use with caution. It sounds good on paper if you're recruiting because you only have to put in JavaScript. But in essence or in practice, being a lead of a multifunctional team, front end, back end, using the same programming language, you might oversee or overlook the differences between how front-enders think and do and skill sets and how backend does. So that's why full stack is, the name full stack might be problematic because which skill set are required to be full stack?
Yeah, I'd mostly agree. I think in larger companies where you have like, you know, teams working on front end and back end separately, it doesn't really add up or add very much to the equation. On the other hand, when you're very small, like, I don't know, our data science team is quite small. It's an important thing that we can say validates our hypothesis and so on fastly and efficiently, and sort of doing some backend stuff and front end visualizations and things like this, or analysis is much faster. For example, if you can actually use the same language on both sides. Might not be JavaScript. I know, Simon, you're on Clojure. Clojure is both front end and back end, so it's F#. I'd be a little bit weird. I'm not really. Does anybody know what's the maintainability of backend projects written in JavaScript? I guess we're a little bit less involved on the backend versus the tooling on the front ends.
Like everything in software development, it depends.
My experience in we see a lot of those in our job. Okay, so the biggest challenge, which from my point of view is both front end and back end in JavaScript, it's the level of churn in libraries and frameworks. So this is a problem both front end and back end. It's the same genetically. There is a super fast churn. Okay, so the approach that was great 3 years ago is now showing all the drawbacks that were probably, you know, not foreseeable when the project adopted that framework 3 years ago. But now it's they want to move to the new one that fixes those problems. Now, what happens is the new one will have its own set of new problems. Okay, just to be clear, whenever you add frameworks or toolings or tooling or things, they, you know, you solve. Typically, it solves something, and it creates some new problems. Okay, so that's usually what happens. So it's which is fun, but it's the level of churn, which means that application now needs to think, oh, I'm staying with old versions, or I am investing the time in updating it to the newer versions, or changing libraries and approaches and grow it over time. And these happen both for front end and back end. So I'm not, maybe it will stabilize over time. So what we have seen is that in the last couple of years, things have stabilized a little bit more. So, but a few years back, like we were, imagine when like all new apps, for example, all new React apps. So the greatest thing is that React moved to React hooks. I could not understand that class model that people used before, in fairness. But now we have hooks. They are great to use, but it's a completely different syntax. Now, React kept the old system compatible with the new one, which was great. So everybody could adopt hooks at their own pace and mix and match. But it's other frameworks didn't do that. So I'm still seeing the some old Angular.js 1 application running around, and it was just like, ah! So it's still there. They're still there. So it's and you know, I'm actually the one saying, well, let's keep it alive, okay? Because replacing it will cost too much money and too much time. That's probably not worth it.
I think jQuery or React overtook jQuery on Stack Overflow most used framework a few years ago. So people still use jQuery to develop their website or maintain old legacy website. I still have websites that I have to support that are 10 years. Yeah, 10 years ago, I started them, and I still have to support Angular.js, even though we're now at a new framework called Angular, and it's probably number 14 or something like that. And at the beginning, the development cycle was too fast. I think for anybody, if you started a new project, it was amazing. If you worked on a project more than 3 months, it was a problem, because the breaking changes was probably in every version, and it was a pain. But like Matteo said, it has stabilized over the years, and now it's like React, Angular, Vue, I think are pretty stable and are, I wouldn't say fun to work with, but it's not a hindrance. It's like, it's doable. But yeah, I mean, I think about JavaScript the same way I thought about PHP 10 years ago, where everybody used it, but the hype and the usageness, people didn't, the programming language or the ecosystem didn't live up to the hype. So it took 10, 15 years for all of the building blocks of libraries, package managers, ambassadors, the ecosystem to evolve, to have something that's great to use, that's fun to use, that doesn't it doesn't bring liabilities to an enterprise project or a project that will have to be developed for the next 10 years. So I think JavaScript is in this weird way where it's evolved, but it's still not quite there, by my opinion. It's way better than it was 10 years ago, where we had NPM and Bower and Gulp and Grunt, and you had to do a lot of heavy lifting yourself until Webpack came and started doing things. So yeah.
Okay, before moving forward, I'm also going to be the voice of the audience and read a comment from Mitya Gaspar, who I found quite interesting, and he's emphasizing that one thing he likes about having the same language on the back end and the front end is also that it's much easier to have teams where members complement each other and split teams by domain rather than simply this kind of binary division front end and back end, which I think is kind of a very fair point. And also just kind of looking at kind of the teams I ran or worked on, I think that for a lot of developers, that it makes for a more interesting job if you have more kind of flexibility and more fluidity in what you work rather than being kind of completely boxed into just one position. Okay, but there's another point I kind of want to touch that Matteo mentioned, and you also kind of now brought in again, Miha, and this is the complexity of the ecosystem, especially in the kind of this broader strategic context, because like one thing where I do, what's very interesting is that for me, it's like clearly the next step in this like long arc we have. If you look at computing, where we had like years ago, we had Visual Basic, which was like the kind of the entry point for many people into computing, which is kind of super easy to tinker with. And then it was PHP, which again, just kind of change small things, something pops up on the page, it's fine. Like you don't have to know all the complexity. It was like very simple, and you can build things. You can like steal code and build things. And then we have JavaScript, kind of like the spiritual successor of this arc. But what my worry here is that with the ecosystem becoming more and more complex, and now having this like elaborate rituals which you have to go through to have like a simple JavaScript project, modern JavaScript project up and running, is like, are we losing this quality of JavaScript? And if so, where do you see like what's kind of next? Because on the one hand, it seems even like, let's say the blockchain, the crypto space, which is kind of the latest and greatest, is also kind of very heavily borrowing from JavaScript, because like something like Solidity essentially is like JavaScript. So clearly they're trying to kind of build on the accessibility of the JavaScript, but kind of in a slightly kind of different perspective, but still, like, is the overall complexity becoming something that is a hindrance to JavaScript, or is going to find a natural progression of the ecosystem?
I think the main thing about JavaScript is it's not like language based, it's library based, like you said on or asked on Facebook. So you're not actually doing JavaScript, you're writing things in Apollo or React or Angular. And I think that JavaScript has that, I wouldn't say problem, but it puts more pressure on the developers of those libraries, because they are the ones who have to create their own ecosystem that plugins work with that framework, or plugins should work with that library. And you have like Happy, which has its own plugin system. You have React and stuff like that in Angular. And I think that it's JavaScript is library based. So if you follow a library or its framework, you are in that ecosystem. So you don't have one big ecosystem, you have several small ones, and the frameworks or the libraries that you use, you're part of that ecosystem. That means that it's, I think, more pressure on smaller communities than, for example, probably PHP, where composer packages can be used everywhere and anywhere, and there's no problems with it.
I'd agree. I think actually that this distinction between libraries and the actual language is, and the flexibility of the language itself is something that lets JavaScript be as let's say as efficient. It's quite a small and lightweight core, and the way that things are added in this to this core, I think it's quite pragmatic, and they're not stuffing all the possible stuff in there. I don't know. On the other hand, I'm following a little bit of C# that I used to program a few years ago, and it seems that they just keep stuffing everything into C#. Whereas in JavaScript, yes, they did add async await, but that was like, you know, it took several years. It was just in the Babel transpiler, and they're adding some stuff to the browser, like web components, which is in the long run also making all these libraries much simpler. So I actually think that their pacing is just right. I trust the process that they've built, and I think they're just, if they stick to this way, it's going to turn out right.
Yeah, and since, like, Miha, like you've mentioned, you mentioned, and you both kind of converge on kind of library aspect. This is definitely something we also see in JobS. Like, for me, I don't know, whenever I see like a front-end position, it's most kind of advertised through the prism of like this, like React and blah blah blah, and some other the technologies. But if we flip this around, what would you say would be like algorithms and concepts that would be good to know for a contemporary JavaScript or like more broadly front-end developer?
Well, that's probably depends on what kind of front-end developer or what kind of JavaScript developer you are. Because if you ask somebody, oh, you're a PHP developer, you know they're on the server side. But if you ask somebody if you're a JavaScript developer, they could be doing React Native, mobile, front-end, back-end, TensorFlow, I don't know, a lot of different things. So I think the main or the most important, if I have to pick just one, is to know the fundamentals of the platform you are developing on or developing for. Because even though JavaScript works pretty similarly on the front end and the back end, the browser and Node.js on the server do have differences, and those differences do matter when it comes to user experience. That's why if I have a person that's doing JavaScript on the front end and they start doing JavaScript on the back end, like Node.js modules and like simple scripts, you have to sit down with them and talk about how JavaScript is different when used on the server than that if it's used on the web. What works, what doesn't, and stuff, right? So I think like the fundamentals of the platform where JavaScript is running is probably, for me, the main thing that a JavaScript developer should know.
Yeah, this relates quite well with me. Like, it's the major difference between front end and back end is that a website, if you are on the front end, you have one human being in front of you. If you are on the back end, you have you need to think about concurrency and parallelism and how this will scale. You have potentially thousands of human beings that you are serving your data to. So you need to take into account a lot of different considerations. So, and it's not even a one-way street, okay? So we can have some computation being done on the front end. We can have the same computation done on the back end. We can do even the computation that is done in between, okay? It can be done like all that edge computing. We can have caching involved so that we can do things on the server and cache it for all users, which is also great, okay? So that the users can receive data real quickly. So it's, there is this level of nuance and being able to understand the full stack, okay? And how the data flows throughout the system, that it's, in order to be an effective full stack developer, you need to grasp and understand, and it's not just using JavaScript.
Your question actually put me on a little bit different train of thought than the others. And what I was thinking is in a way that we've brought into JavaScript lots of concepts and libraries that have been developed elsewhere. So for example, in React, there's Redux. And Redux is sort of following the Elmish or the Elm store model, out of which then we also got this immutable data and things like this. And once you try it actually in Elm, it makes much more sense than the way we adopted it in JavaScript, which is in some ways it's a little bit of impedance mismatch, a little bit due to language itself and the environment, what's feasible in JavaScript and what's not. And I would suggest people, if they have time, to actually check out those things also in the way that they were developed in their natural languages. Even, for example, React hook is also I'd say a monadic concept taken from somewhere else, and it's a cool thing to actually understand that thing on a say not theoretical but on conceptual level, where it's coming from and what it's doing.
We have another also comment from the audience, and Sasha Vucic says that he thinks that the complexity is far more prominent on the front-end side rather than the back-end, and it's far easier to spin up and understand the tooling on a pure back-end Node.js service compared to a React project, for example. Is this something that kind of mimics your experiences?
Sorry, can you repeat the question?
No, it was more like a comment, not a question as such. It's just like the point was that he reckons that the complexity we were mentioning is more prominent on the front end side, and if you look at kind of just using Node.js on the back end, you don't have all this kind of ecosystem complexity.
I would disagree. You have a lot of possible complexity. Like, I've seen projects get very complex very quickly. on the back end as well. Now you can, as I said, you can give people a lot of rope to hang themselves, and they're pretty good at doing that. Okay, like again, you have like the worst pipeline for this was, oh, I want to expose a GraphQL endpoint, so I design my database, I create a SQLite, instantiate a SQLize ORM on top of it, then I use my SQLize to generate the types, and then I feed these to a GraphQL server. Now, what can go wrong in this kind of setup? Okay, that's, it's and then everything. Then you run it, and it's fine. You develop it in no time, but then you start running it in production, and it hammers the database, and it's totally unscalable software. So it's at least that's my view of the problem. So probably slightly different. The outcome of it is different. So you probably will experience the same problem with different smell after a little bit of a longer time on the back end than the front end. It's probably more forgiving at the beginning or something.
I think most complexity that's present in project, it's the hidden complexity where the approach on how to solve a business problem with that framework or library is done. I think front ends and back ends and everything in between have the same amount of complexity. I think what's more front end, you have probably only 2 or 3 popular front end frameworks that pretty much most people use: React, Angular, and Vue. And then you have Svelte and some others. But how many backends you have in JavaScript, or if you add other programming languages, there's like hundreds. So I think we all pretty much have the same complexity. It's just a different complexity when it's on the back end and if it's on the front end. I started with front end, so the complexity of view model, views, and models is pretty natural or intuitive to me. But looking at this distinction or the separation of concerns in a backend, everything seems complex. But if I was a backender, the complexity of having a CSS and all of the rules and stuff like that might seem complex to me. But I think that front ends and backends hold the same complexity, and I don't think that's the frameworks don't offer either sides a easier way of developing.
Yeah, I would say that there's just as much beauty in doing development on the back end, on the soft end, on the front end, and it's more like you live in a different media. It's this discussion is like, what is it better to be a bird or is it better to be a fish? It's sort of, they're in many ways they're not comparable, but then at the same time, I'd say there's this art of programming that you can perfect even either on front end or on back end, where you do simple and composable code that does not turn into a spaghetti code once the project grows big. And yeah, and I would just call it like, the art of not shooting yourself in your leg. So and apart from that, yeah, I love both front end and back end. It's just, if you like programming, it's just, yeah.
Kind of to switch tracks for a moment. Are there any paradigms or approaches you would like to see used more often, but are not, either due to the lack of awareness or maybe kind of just the tooling and the ecosystem representing more friction of using those approaches?
I Of course. I mean, I've done Android development, iOS development, front end, back end, and every few months there's a library that does something new in a language that was already been done for years or decades even in other programming languages. Either paradigms like I said, model, view model, the thing that Android, like console, after 15 years or 10 years of Androids, we finally have something that's a usable architecture, which should be, by my opinion, applied to probably most state machines used in front-end components, even React or Angular, where you have view models and what Redux does, but in a different way. And I think the main thing is that a lot of things that are already present everywhere else are brought up as a new thing in a library or framework. And I think that the biggest boon to our productivity would be if every programmer or every developer used a couple of different development programming languages as well as frameworks, because Angular does some things great that React doesn't, and React does some things great that Angular doesn't. And you're like monkey patching each framework to use the better things of a different framework. And I think that the transmission of knowledge of those paradigms is few and far between. And I think that all of the paradigms that are already present in iOS development, Android development, backend, frontend, even old school Perl programming and stuff like that should be adopted faster, or at least taking learning from history to not repeat like the same mistakes where after 2 years we know now how to develop a stable front end in React or in Angular or stuff like that.
Matteo?
Well, it's the popular frameworks or programming languages have all have a shared shared roots to some extent. Okay, I think technology runs in a spiral. So there's very little things that are created anew, okay, in the field. It's most of the biggest discoveries have been done in the 80s and the 90s, okay, 70, 80, 90s in the field in terms of research. What is happening is that each generation of software, it develops new frameworks, new libraries and things to improve the previous generations. So, and from time to time, there is a bigger jump, okay? And it typically is a jump from scripting language to compile language, like some of those is from scripting language to compile language, from compiled language to scripting languages, okay, or something like that. As I said, it's a spiral. The same ideas return with different and new concepts. Let me make an example. Okay, a lot of developers really like GraphQL these days. Everybody loves GraphQL. Okay, so there's a single, which typically is consumed as a single HTTP endpoint, which you interact with a post, and you send a JSON as something with some custom query language on top, and you receive some JSON back. Now, when I some years ago, okay, it's what we were doing. We were doing SOAP and WSDL, and I you know, it's so, you know, bear in mind, in GraphQL you have a schema and you have a query language, and in WSDL is the schema, and then SOAP is the message that you are passing, that we're applying to that schema. Okay, it's the same pattern, exactly the same pattern, built with different technologies, solving the problems of the previous generation. What was supplanted by that was REST as one, because that approach was way too complex and doing XML processing was super hard. So turns out that we wanted to use JSON, which is a less featured data format than XML that was way simpler to parse. So again, as I said, is a circle. But by the way, JSON, it's only simpler to parse if you're using a scripting language. If you're using a compiled language, more or less is very similar to parsing a WSDL. So a SOAP message or an XML. So anyway, what I wanted to go back to is like technology works in a spiral. So it's a new generation built on the previous generation, improving things, making things more productive, and making things more productive at any turn. But the core ideas are always the same.
I'd continue from where Matteo left, where he said that the most important stuff in computer science were actually developed in 1960s and 70s and so on. So one thing that we had in computer science was that, like, in late 50s, they invented garbage collector, but it took until late 90s that we actually started using it in Java. So it was almost 40 years. And another thing that I've discovered, also another 70s thing, is called Curry-Howard isomorphism, which actually allows you, if you're using type languages, but not the kind of type languages where you tell the compiler this is string and this is an integer, but more of semantically, then actually it was separately discovered by both mathematicians and the computer scientists that you can actually write a typed higher level interface program of your software in the types, and then once you, and that's sort of similar to a mathematical theory, and then when you actually write your code, it's a proof of that theory, and what happens is the way that you're sort of, by programming, you prove that your program is correct. And nowadays it's becoming slowly into our attention. For example, Rust is using part of this thing for maintaining this memory management and so on. But we had other languages like Pony, which is an actor language, was using this stuff in order to figure out who can concurrently use various data structures. So if someone's actually writing it, then the other thread cannot be, and so on. And then there are languages also on front end. Elmish or Elm is actually doing this, and so is Clojure. Then no, Clojure is untyped. What's it? OCaml and ReasonML and so. And it's slowly trickling also, say, in TypeScript, though I'm not really sure that they'll be able to go full way in TypeScript. But for me, this was one of the biggest revelations, like in programming. It was I would say a step on the same side as going from jQuery to React. Is going from normal languages to fully typed languages that actually support proving that your code is correct, and mostly because, first of all, it's much easier to refactor, and and you don't have to write as many tests. Like you get more than half your unit testing for free by just language actually inferring what you intended to do, and so that's something I'd clearly suggest everyone to learn. Maybe we won't have to wait another 50 years before everybody is getting this thing, but we don't know how far it is, but it's here. So yeah, that's my point of view.
Awesome, thank you very much. With this, I also like to kind of open the discussion wider. So if any of our dear audience have any questions, please do write them out and we'll try to get to them. And maybe just kind of while you do so as a closing thing, so we don't just sit here in silence and look at each other, how do you, all three of you, see a world where we burn it all down and build it back up? So kind of a JavaScript ecosystem without the burden of the last, 30 years of history, and what would that look like? But first and foremost, yes, please do write out the questions so we can kind of have a more discussion on this and hear from more different and diverse voices. So JavaScript from scratch.
Can I answer? I don't want to burn anything down because all of the pressures and all of the history is something that's very important, because the history and the problems and the boons a programming language or ecosystem has helped it develop its footing. So I don't want to burn anything down. I would actually introduce more chaos into it, because then you have good solutions and you have good approaches, better approaches to the chaos. And this is the only way how to fight entropy, is to get better solutions and evolve it, improve it. So I would, yeah, more chaos is better, because I think the human ingenious will overcome any chaos. So just put more stuff into JavaScript and let's see where the smart people take us with new approaches, new libraries, new frameworks, new ways of thinking. So I'm actually quite enjoying the whole show with JavaScript, because even though I'm not a fan of it, it has helped the web development immensely. I think even more than PHP did 20 years ago or 25 years ago. So if JavaScript is doing good, everybody is doing good. The users that are using mostly web stuff, as well as developers actually using all of the frameworks and libraries.
I think there is a place for a language like JavaScript, and considering it was written in 7 days, it's amazing. There's this special thing that allows it, for example, that allows JavaScript to be compiled and into a JIT code that's approximately 50% as fast as compiled C code, and you don't get that from neither Python nor Ruby nor any other language. So from that perspective, it's awesome and it's amazing. I might change a few things though. For example, the fact that the numbers are just floating points is, and that we have the double and the triple equal and things like this. And Tony Hoare said that inventing null pointer was a $1 billion mistake, and now we have a language with both a null pointer and undefined. So. So there are a few screw ups, but all in all, okay. I would take it. I would take it. It was a well done thing.
I just remembered which thing I would change in JavaScript land. A package manager. I think the future of, I mean, it's the present. We reuse each other's code. Open source is like the most important thing ever. and having a package manager that's a joy to use would be a welcome addition to JavaScript. I know it's a hard problem, but if I could change anything, it would be a package manager that I would say just works.
So for me, there are quite a few things that I would change. Okay, so first of all, it's I do not regret all those words that we get from the beginning. Okay, especially if, like, given the history of JavaScript. Okay, I don't think that was. I think part of why JavaScript was so successful, were all those words that resulted from that very early startups. I'm to be honest, there are like probably the equals, all those things will need to be fixed, would have needed to be fixed at some point. Okay, now it's too late, but if they were fixed, it would have been a better word. The major thing that is for me, it's a massive. There's two massive regrets. And one is ECMAScript modules, ESM. That it's a massive regret that could have gone way better, and it didn't. Okay, it's still not going well. As part as we have made a lot of progress, but it's still not there. So yeah, so that's for me the main one. The other ones are, for example, promises and so on, that were not. They probably could have been put a little bit more thoughts on those two things. And so promises are great, but there are also a lot of foot guns in their usage, and it's certain things are not, could have been done better to some extent, or not better, but it's with a little bit more open mind on where things could have been used. So both ECMAScript and ECMAScript modules and promises were mostly thought and designed from a browser point of view. So while we run JavaScript everywhere now, okay, even watches run JavaScript, fridges run JavaScript, like it's literally everywhere. So it's
spaceships run JavaScript.
Yeah. Yeah.
So Simon, why do you hate JavaScript?
Fair question. Like you've already touched on some of the things, but I think they're kind of a symptom of a broader issue that when it was designed, it was kind of had this, like a bit of a unclear positioning, or rather, I think it was meant more as a quick fix. And this is something you often see in scripting tools. And historically, it's always been a huge issue when you just kind of build like the minimal possible scripting tool you can, or just have like, start with some configuration language and then just add ifs and for loops, and suddenly you have a Turing complete language, and it's complete utter shit. And we have like a long history of those. And in many ways, it feels like kind of the genesis of JavaScript, and in other ways kind of similar to that. So like, while on the one hand, as I already said, like one thing that I see, and but for me, by far, the most important thing in JavaScript is that it is very accessible. That yes, you can use source and you can kind of start it. It's like one of the few areas where we still have those computing building blocks being readily available to everyone without any kind of special tools, without much special launching. It's going to start and tweak with it. But as a core, if you compare it to what kind of state of the art of languages, or even like what the state of the art of languages was in the 80s, it is rather poor in other ways. Like the type system is kind of a complete mishmash. It's inconsistent in many ways. Like the prototype system is interesting, but at the same time, it is quite obscure for what JavaScript then end up being. That's also I think it's kind of a mismatch. Like I find prototype inheritance interesting, but I think it's kind of doesn't serve, like if you want to build a system or like a language that's accessible to as many people as possible, that's probably wouldn't be my first attempt. Oh yeah, let's just kind of inherit from distinct objects and have this kind of weird way of how inheritance works and how identity across objects works and stuff like that. And then you just have like, and because of like, and then those decisions pile up. Like a great example of this was also in the talk Matteo gave, and how like the issue, like the workarounds you need to make to have like a stable node, like something stable to do content addressing, and you have to go like, oh, a special JSON serialization library which dumps an object to a string just so that we have a stable representation. This is like, for me, it's kind of a direct result of some poor decisions in how the language is been designed, that you don't have a better notion of immutability where necessary, or that kind of things like ordering can have such a big effect. And it's kind of, and there's like a list of those things, and then together just kind of make a friction. I do think that the overall the language and the ecosystem have become massively better than where they were. And I do agree with, like, all of you were mentioning kind of this two-way street of, on the one hand, yes, various languages compiling to JavaScript, and on the other hand, JavaScript is kind of also absorbing all the best ideas. And I think kind of the JavaScript in the year 2021 is a much more pleasant proposition to write, but at the same time, you still do have all those kind of limitations of the language that you then have to, at the best, work around by using different kind of libraries that can kind of work on top of that. And it's going to simply, as a core, it is not a very sane core, also not as minimal as it could be, but it has like bloat in some areas and is lacking others. So you're going to have to complement it, but then doesn't have very obvious things like a package system, as Miha already kind of mentioned. And at the same time, also as a building block, it is not as malleable as something like a Lisp is. So kind of, as a building block for other things, yes, you can build other things because it is still like, it is a dynamic language and you can do monkey patching and stuff like that. But again, it is something that like, or even something as Ruby, something like Ruby, or even Python gives you way better metaprogramming capabilities than JavaScript does. So just kind of, in ways, I feel that it is too much of this kind of lowest common denominator, and that just kind of makes me sad because it is so prevalent.
It's related to the metaprogramming, yes, but those languages are incredibly slower.
Well, the Lisp's not, but the other two, I agree. But I do think you can have both, to be honest. I don't think that any of the decisions that were, and also like even like Python, like with C Python and stuff like Python can be fast. Like if you look at what people are doing in the like SciPy community and stuff like that, where a lot of libraries kind of are done thinly underneath jump to C. So I don't think that the facilities of the language represent that much of a penalty. Yes, it is like for many things, it is slower, but I think like a lot of those things could also be worked around if those weren't actually issues. I think those are kind of where Python is slow is a reflection of how it's being used. And that's kind of pushed more and more towards being used, let's say, for data science and scientific computing, where the focus is on other things. And while the areas where it is used on the backend, I don't think they are as performance critical in most parts. And there's just like not that much work being done on optimization. But also like, Peter, you want to add something?
So yeah, two things. I've actually been a huge fan of Python. I've been programming Python back in 90s, where there was still Python 1.6 and the NumPy just came around and so on. And after I learned JavaScript, like in the depth and so on, I actually find JavaScript to be a better language than Python. So that's my view. I think I'm more expressive with it, and also you'll see more of, let's say, computer science actually going on in terms of like, how you can mold the language to get to certain results in JavaScript. So, Python didn't give us React and reductive and async await actually came, say, from JavaScript to Python and so on. So, and the other thing that I thought is, is in a way, I think, Intel has this x86 architecture that we've had now, 12th generation, and it's still sort of the same 16 registers inside that CPU that we tend to program against, and we call this the instruction code architecture. And I think JavaScript is okay, it's just to end to that thing, but in reality, the CPU that's actually running that thing is then translating that into an internal CPU that actually has like 500 registers and is doing everything very super scalar in its RISC or very large instruction work and things like this. And I think JavaScript is probably having a similar fate. It's still evolving, because like software is easier to evolve, and we're not limited to the instruction code size and so. But I would say that it's going to be the golden standard, and it's going to stay around for a very long time, and we're going to be programming it against, just like we're programming. Say we have this virtual machines for JavaScript and Java and .NET and who knows what. So yeah.
I have an additional question. Do you think that JavaScript will become the golden standard, or has become the golden standard, because most of us are doing web development, like 60 or 70%, and JavaScript is a web language, and most people know JavaScript. That's why it's a golden standard, or it's the language itself so much more appropriate for the work that the majority of people are doing?
I think it was a sad accident that it happened. Just like every other programming language that we're using nowadays was just a sad accident. So C was a sad accident that somebody wanted to write something that was easy to program PDP, and PHP was a language written to do HTML templates, and Java was a language to do TV sets and DVDs and so on. So it was just on the wrong place and on the wrong time, or maybe on the right time. But still, it turned out really, really well. Yeah, that's my opinion.
I mean, I think we're in the golden age of web development, because it's very easy to develop. You don't have Internet Explorer. You have a set of like standards that most browsers or most users that are using those browsers like have. CSS3, you can do pretty much everything with it. You don't need even Bootstrap and grids and rows if you're a design front-ender. And it's actually very enjoyable to do web development. And it doesn't matter if you're doing it JavaScript, PHP, C#, all of the frameworks allow you to do pretty much everything at an enjoyable level. Because 10 years ago, when I started doing PHP, which was web focused, it was actually a pain. But now I can set up a JavaScript API in 15 minutes. It will respond to requests in JSON. It will connect to a database, and it takes me 15 minutes. And
I think that the highlight of this evening, at least for me, was Matteo's statement about the backend in JavaScript, which is there's so much flux and so much churn. So things are moving, and I think this is part of the trouble with JavaScript, but also part of the success. We are willing to keep up with all this churn, so that's why JavaScript is evolving much faster than all the other environments.
Well, like one thing kind of popped to mind is that I find very exciting, even though it's not something we kind of talk that much about in terms of technology, but just kind of the possibilities is that now we're at this stage where you can have more or less complete applications running completely on the browser side again. So kind of, have this like pendulum between server side and client side. And now, basically by virtue, for a large part of the Java ecosystem, plus maybe some advancements in the serverless land, we're now in a position where you can have very complex applications that run again almost completely on the user side. Like a great example of that is Roam, which is a spectacular note-taking tool, and that thing runs almost exclusively on the client side. And I would like to see kind of more of that, also just because it opens up that much more possibilities of tinkering, which I think is something that we should, like any kind of discussion for me about the future of computing should very much include this kind of notion. Like where we came was in very large part because so many people could just kind of tinker, because there were no gatekeepers, because you just kind of like have communities online and just like grab the source and do something with it. And this is kind of like, this arc of history goes back to the 70s or even sooner, and it is something we, especially now with kind of more and more closed gardens and very well-created ecosystems, well-created hardware ecosystems, we do have to be careful that we don't lose. And kind of, but to conclude, we have one last question from the audience, and like Sasha Vucic is asking, what is our opinion on TypeScript, and do you think that it will become the default?
I love TypeScript as I love Kotlin, but it won't become the default because JavaScript in itself is good enough. It doesn't need to be TypeScript to be successful, but it does offer pressure to the JavaScript programming language where they can take, or JavaScript can take the good things out of TypeScript and include it in itself. And on the other hand, because TypeScript is a superset of programming of JavaScript, you can still use TypeScript instead of JavaScript, and you get all of the things for free or for a small cost. So if you have a project that type safety is probably something that you should have, well, just use TypeScript. If you don't have a project that needs type safety, well, JavaScript is good enough. I mean, there's nothing inherently wrong with JavaScript that you have to use TypeScript, but it helps for bigger projects with types, and a lot of things can be caught even before running the code.
I'm positive about TypeScript. I think so. It has this some types and
sorry, Peter. I
Yeah.
need to interrupt. I really need to drop, guys. Sorry
Okay.
for me. It's my time is up. So thank you for having me for tonight. And I really need to go now. So thank you, folks, and see you next time. Bye bye.
Thank you. Bye.
Bye bye.
Yeah, that's a shame he went. Yeah, so yeah, I'm positive about TypeScript. I like it. It's just that from my perspective, it just goes like say 80% of the way of having really properly typed languages. It's a good step in the right direction, but I think sort of if you really like the type safety, then maybe go with Elm or F# or something like this. So.
Okay. Simon, do you want to just have some closing thoughts, or?
No, I think we had enough points where it was kind of would be perfect time to end. So I'm not going to. But I would like to thank all the kind of panelists. I think the discussion we had up was quite lovely. Like very interesting points were raised. So thank you from my side. Also, thank you for the questions from the audience.
And also thank you everyone from our side. I really, I know that we provided a lot of value added with this discussion, and I hope also answered some questions, or maybe even encouraged some people to not be so bitter about JavaScript, I guess. Again, just thank you from our side, from IT class. You have you see the links where you can reach us, and yeah, we will see each other on our next event, hopefully this time really live and in person. Okay,
Yeah.
so, yeah, with this yeah, we will conclude, and thank you so much everyone, and yeah, bye.
Thank you. Bye.
Thank you. Bye.
Bye.
Okay.